Hello everyone, welcome to another Ignite Robotics training session. This is the first programming training session on the REV start bot. So following the meeting that happened last Saturday, recording also up on the YouTube channel, where I walked through how you can go about programming, or at least the first half of programming the Go Build the Starter bot. This recording or video is going to be on what you have to modify of that code to get it to control the REV start bot. And so this is basically for the fact that some of the Ignite teams will be getting REV kits, some of them will be getting Go Builder kits. Most of them will be Go Builder, there'll be some REV. It was just a bit of what was cheaper at the time when we were ordering them in separate batches and shipping and stuff like that. So that's why there's some of each. So that's what we're going to be covering in the weekly meetings on the Saturday for the next few weeks. We're going to be covering the Go Builder starter bot, and then I'll probably be doing a recording after that showing what exactly you have to modify for it to work on the REV starter bot, because the concepts are very similar. It's just the motors and the servos are kind of in the same place. It's just actually different motors and servos. So how exactly do you account for that and stuff like that? Then, because the screen recording also did not work so well on Saturday, I will be just doing a quick overview of what the code does, so that everyone can see it from that video as well. And it'll also just help you get to grips with it before I go into what needs to change for the REV starter bot. Okay, so what do we have here first? So the first thing we did was we got our two drive motors. It's an omni-wheel drivetrain. So there's two drive motors controlling the four back wheels, and then there's two omni wheels at the front, which will allow it to spin on the spot, right? So what we did was we just initialized the configuration to tell it which ports it's controlling or which ports the drive motors are plugged into. Then we made sure to reverse the left motor so that when you set them both to power 1, they will both move forwards. This is necessary because when the motors are mounted facing opposite directions, they will by default spin in opposite directions when you set them to position 1. So make sure you reverse your left motor. Then we said run without encoder because we are not going to be using the encoders on the drivetrain. It's just going to be a set power from the driver. So then finishing off the actual drivetrain code down here, we have these variables over here that are taking input from the driver, right? So if the driver presses the joystick, the right joystick Y, which is vertical, then the robot will move forward when you press it forward, and pull it backwards, you want it to move backwards. And so because these joysticks are reversed, we just want to take the opposite value of it, which you just put a minus sign there. Same thing for turning, except we don't want to reverse it because the side-to-side movement of the joystick is fine. We just take the normal left joystick, so they control the turning on the left joystick and the moving forward and backwards on the right joystick. Then we actually just apply it to the drivetrain like this, so that the driver can turn and drive forward at the same time. If you want a more detailed explanation on this, then go watch Saturday's video on the channel. Then the other thing we worked on was controlling the arm, right? So the arm is mounted on a shaft at the top of a bracket and is controlled by a motor with a gear, in the case of the Go Builder one. So we just have an arm motor up here, right? And then we initialize it to the correct port, and then we stop and reset the encoder and we set it to run to position. So this means that we're going to actually use the encoder in the motor to tell it to go to a position. And this is built-in code that will actually run the motor to the position we want it to go to. So then the last thing we needed to do was to actually define what position do we want to go to. So that's one thing that Go Builder gave us, which was very nice, was this arm ticks per degree, which basically means that now instead of having to input a target position of the arm in ticks, which we don't really know or understand very well, and it doesn't give us a good reading of where the arm actually is in space, you just have to have a trial and error method to get to the right place. It allows us to give the arm a certain amount of degrees to move, and it will move that many degrees in real life, but it will convert that degree amount we want to move into ticks that the motor can understand. So then what we do here is we just have some variables, right? We say the type of variable, so an integer, we want a whole number because encoders can only take whole numbers, they can't take decimal points. Then we set the name, so this is the collect position, and then the number of degrees multiplied by this value, which gives us the ticks, right? So we're saying we want to go to 250 degrees for the collect position, and we multiply it by the ticks per degree, and that means this collect position is going to tell us, or tell the motor, how many, what target position needs to be in ticks to reach this position in degrees in real life. So then what we would just do is we'd say gamepad A. So we're saying this is an example, right? If the driver presses gamepad A, then arm motor dot set target position to the collect position, which is going to then move it to 250 degrees in the real life space of the arm. So that's a quick overview of what we kind of covered last week. Now, what exactly do we need to change for this to work with the REV starter bot, right? So if we go here to the REV starter bot, you can see the actual starter bot compared to the Go Builder one looks very similar in terms of the fact, and the concepts are very similar. It's got 4 drive wheels, right, 2 on each side. Then it's got 2 Omni wheels, and it has an arm here mounted on a shaft that is connected to this motor. You can't really see it back there, but it's the end of the motor right here. So the actual code is very similar, right? For the part that we've done on Saturday, and I'm showing you here. So what exactly does actually need to change? The only thing that we actually need to change is the position the arm goes to, because it's different motors, a different motor. It's got a different gear ratio. You can see here, small to big. Same thing for the Go Builder starter bot, except that it'll be a different gear ratio, so it'll go a different speed, go to a different position. Now, REV doesn't give us a arm ticks per degree value like Go Builder does, which is unfortunate. But what they do give us are the target positions right here. You can see this is, if you come down here, you can say features, links, teleup code, and configuration examples. It'll open up here, and you go down to onboard Java overview. They go through a whole lot of block stuff, but we're not going to focus on that. So you scroll down to the bottom, it says full code, and you can come see here. You can see they also store the position or the target position for the arms in variables. You can see arm position init, arm position intake, arm position grab, whatever. Now, this, as you can see, are in the 1,000 ranges as well, which means that it is in motor ticks. So REV doesn't convert the ticks into degrees for us. They just give us the positions that it needs to go to in ticks. So the way we would need to do to modify this code then in Android Studio to work for the REV bot is, maybe what I'll do is I will just copy, paste, starter bot teleup REV. So we keep the Go Builder one there. So now what we're going to do, we don't actually want this because that's the Go Builder thing, right? What we can come over here and do is, you can see arm and wrist target positions. So these are the wrist ones. We're not going to focus on them right now. We're just going to take the arm positions. We're going to copy them. We're going to go over here. Right, and we can just paste them in. So now we have all of these things that store, all of these variables that store the target positions for us. So now instead, go down here, we say arm init position, right? We're in the init over here. We want to set it to the init position, and then we can go, for example, again, we can say gamepad A dot whatever we can say. Well, what do we want to say? Intake, right? Same thing. So we say arm intake, and that will set the target position of the motor to arm intake. That is actually all that you need to change for this code to work with the REV bot instead of a Go Builder bot. You don't need to do anything with the drivetrain code because we are not using the encoders. It's just a set power of the motor. The right and the left motors will be the same. The left still needs to be reversed. And again, you just have to make sure you've got it plugged into the right ports. The reason the only thing that would actually change is stuff that doesn't have to happen in the code, right? Your code's still going to control the drivetrain the same way. The motors might just go at slightly different speeds, which means the drivetrain drives slightly faster or slower. I'm not sure which way around it is. But you don't actually need to change anything in the code for that. So that's it for this recording then. That should give you a brief overview of what we did on Saturday and then also what you need to change for the start bot for Rev. Um, if you do end up getting a Rev kit and not Go Builder kit, then I sent the Go Builder resources on the Discord already, but this is where the resources are for the Rev starter bot. I will also post this in the Discord now as well, along with this video recording. Thanks so much for watching, and hopefully I'll see you either in the debugging session this week or on Saturday again, for the next installment of this. Cool. Thanks so much.